So now let us do from the question 10. Sketch the region bounded by the graph here and another graph from x is equal to -1 to x equal to 2. Please look at the notes I gave you about areas between curves. November 11. It is explained very clear here. In order to find the area enclosed by two curves f and g, we take from the interval from a to b, we take the integral of the absolute value of the difference f and g. So the absolute value sign here is tricky. We want to get rid of that. Okay. So if we know where f is larger than g or g is larger than f, we can get rid of the absolute sign here. One way is to do some algebra. Assign the function h is the difference of f and g. So we will know where f is larger than g or where g is larger than f. And in this case, in the intervals from 0 to 1, which are the intersection points, g is larger than f. Therefore, the absolute value here of f minus g becomes g minus f. And we just substitute the value of these, do this integral. Okay? That is the one way. Another way, if we know the graph of the function, then it is also easy. So now let us try to graph it. Here, let us try to graph this function.
Could you find if one is bigger than the other by plugging in a number?
I'm sorry, say it again, please.
Could you plug in 1 for x in both of the functions, and if one is bigger, wouldn't that make the function bigger? So if you put 1 for x, and you'll get 5 for y equals x squared plus 4.
Okay.
And you would get 1 for y equals -x plus 2.
Yeah, let us try to sketch it first and see how it looks like. Okay. Because now, without seeing the graph, it's not easy to tell anything. You can do algebra, like I shows in the notes. Okay, now the function x squared plus 4. Let us try to graph it first, right? In order to graph a function, you can do the whole list of things, take a derivative and stuff. But now this is not difficult. And we know that x squared is the curve concave up at x is equal to 0, which is the y-intercept. It will be, the y-intercept will be, what is it?
4.
Very good. 1, 2, 3, 4. 4 here, right? It means if x is equal to 0, y will be 4. This point belongs to the graph here. Let us define it as f of x. Okay? If it is 1, 2, 3, -1, -2. And at x is equal to 2, this here, 2 squared plus 4 give us 8, right? Can you see my screen, Vikram? I'm sharing now.
I don't, but that could just be me.
How about everyone else? Can you see my
I
screen?
see it. I can see it.
Yeah, I'm sharing it. So, and many other people can see it. You may have to reset your computer, restart it.
All right, give me a sec.
Yeah. Then at x is equal to 2, y will be 8, right? And because this function at -2, it also gives us 8. Okay, very good. So the graph of the function f will be like this. Okay. Now let us draw the function g here. Let us find, because it is a linear equation, right? So if we find 2 points, then we're good. What is the y-intercept of this guy?
Two
Y-intercept,
is 2.
yes, 2. So this point, 0, 2 belong to this line. What is the x-intercept? X-intercept is when y is equal to 0. When y is equal to 0, then we know that, okay, x is equal to 2. So it means that the line here will go through the point here. Right, this is the line g of x. Okay. Now the line x is equal to -1. -1 is here. So x is -1 is this green line. Let us draw it like this one. Okay. At x is equal to 2. This is the line x is equal to 2. So do you all see the area here? This is the area we're looking for, right? According to the graph, the function f of x here is on top of the function g, right? Therefore, the area will be the integral. Can you tell me how you can do it here? From where to where? The limit.
-1 to 2.
Very good. Right. And here you can see that the red line is on top of the g line here. It means f(x) is always larger than g of x. It means we can get rid of the absolute sign here, which gives us integral from -1 to 2 of here x squared plus 4. That is f. Now let us write it slowly. F of x minus g of x. dx, right? F of x is x squared plus 4. G of x is negative x plus 2. Okay? It becomes a very simple integral. So how can you solve it? What do we have here in the integral? X squared, right? And the first order we have, what is it?
Plus x.
Yes, thank you. And the numbers here?
And minus 2.
4 minus 2, which gives us 2, right? Dx. So integral of a sum will be a sum of integrals here. So our job is to find the antiderivative of each of them. X squared here, antiderivative of this, we add 1 to the power of this guy, like this, right? The same story. Plus here is x squared divided by 2, right? Same trick. And x from the lower limit, -1, to the upper limit, 2 here. Okay? Is it clear up to this point?
Yes.
Very good. Let us simplify it. This is 1/3 x cubed minus x squared over 2 here. Oh, plus, I'm sorry. Plus 2x here. When x is equal to -1 up to 2. So this means that it becomes the upper limit, which is, we replace x by 2 here. It is 1/3 2 cubed plus 2 squared over 2 plus 2 times 2. That is the evaluation with the upper limit. Now we evaluate the value of the lower limit, which will be, what is it here?
1/3 times -1 cubed.
Very good.
Plus
Plus, thank you, Marisa. Okay. Then let's compute it. I think you can do it yourself. Okay. It's numbers. And the result finally will be 21/2. Okay. Double check it yourself. Do you have any question about this?